All right, 36. F of u is equal to u plus 1 over cosine squared of u. And u is equal to g of x, which is equal to pi x. And x is 1/4. So I'm taking the derivative of f of g of x. So basically I'm taking the derivative of f, and then the derivative of g, and then this gets plugged in anywhere we see u, because u is equal to g of x. So we've got the derivative, I'm just going to write it as y prime because, you know. So what is the derivative of this? Or maybe the better question is, how should I think about this? U plus what?
U plus cosine square negative 2.
Like that. Because then that way it'll be easier to take the derivative of. So then the derivative of this would be what?
1 plus negative 2.
-2.
1 plus negative
Or well, it is going to end up being plus, but because the derivative of cosine is negative sign, but the -2 in front, so it is going to become positive. Then 2 sine of u to the -3. And what's the derivative of g, but what would u prime be? Pi. So then I'm just going to go ahead and multiply by the pi down here. Oh, we missed something here.
Don't you have to like cover up what's in the parentheses and put that?
Yeah.
I wanted to ask, but I didn't have a question.
I was like, wait, something's wrong. I was like, this problem was too easy. Yes, it should have been 2 cosine of u to the -3 times then the derivative sine of u, and we just still went ahead and the negative out front is still fine.
Now we can put pi in.
Yes, now we can multiply the whole thing by pi. And it's the whole thing getting multiplied by pi because we have this 1 plus out here, so we need to make sure we do that. So I'm going to leave the pi out here for the moment while I deal with this. So now I've got the derivative part set up. Anywhere there's a u, I now need to put pi x. So this is going to be 1 plus 2 cosine to the -3 of pi x times the sine of pi x all times pi. So now at this point, we replace x with pi over 4, or sorry, not pi over 4, with 1 over 4. So we've got 1 plus 2 cosine to the -3 of, it ends up being pi over 4, times the sine of pi over 4, all times pi. I'm going to go ahead and move cosine to the bottom since it's got that -3 on there. So this is going to be 1 plus 2 over the cosine cubed of pi over 4 times the sine of pi over 4 all times pi. And so now at this point, I need to think back to my unit circle because I'm trying to just get a numerical answer here. So what is the cosine of pi over 4? Root 2 over 2, and we're going to be cubing that value. So this is going to be 1 plus 2 over root 2 over 2 cubed times the sine of pi over 4. Root 2 over 2 all times pi. So the nice thing is 2 cancels here and here. Now this part I'm going to work with on the side over here just so it saves me from having to do this all, a whole bunch. So root 2 over 2 squared would be 2 over 4, right? Times root 2 over 2. So this ends up giving me, root 2 over 4. So then when I put this back in, basically I have 1 plus, keep, change, flip. So basically I'm flipping that one. So 4 over root 2 times root 2. That was all that was left there. Are we tracking with what I just did? So I had a root 2 over 2 cubed left on the bottom. By the time I was done reducing it, I was left with root 2 over 4. Because it was on the denominator, I flipped it. I basically did a keep, change, flip just on that part. Which you can't see when I stick my hands over it, because... There. And don't forget the pi. So now, root 2's cancel, which leaves you with 5 pi. Now, you could have probably gotten there in less steps than I did, but more so just trying to make sure you see everything. And if you need to do stuff off to the side ever with a problem like that, so you're not just writing it over and over again, I would say go for it, because All right, any questions on those? Okay. So the last thing we have says, find the equation of the tangent, or the line tangent to the curve at the point defined by the given value of t. So, nope, I lied. We will do that. That's 42. We're doing 40 first. 40 says find dy dx if y is equal to the sine of x squared plus 1 by writing it as a composite with, there's 2 different ways we're going to do this problem. They look like they all went together. So y equals sine of x squared plus 1. And the first one they want it to be done is if y is equal to the sine of u plus 1. And u is equal to x squared. And then the second time they want it done, they want it done as, and it's only going to take like 2 lines, so y is equal to the sine of u, and u is equal to x squared plus 1. So basically we're doing the same problem 2 different ways. So I'm going to do the same thing I was just doing up with 34 and 36. So what is the derivative of y?
Is that a product rule?
No, it's the sine of that.
Oh, gotcha. So it's happening.
Cosine.
and then derivative of u.
Oh,
2x. So then to combine it, we would get 2x cosine of x squared plus 1 because we have to replace u with x squared. I honestly hate the ones where they give it to you in pieces and you have to do it. I like just doing it by myself better. I don't like doing it the way that, I don't know. It just irritates me. All right, so then part B, y prime is cosine u, derivative of u, 2x, and so then combine it and we replace u with x squared plus 1. We get 2x cosine of x squared plus 1. Wow, they're the same thing. So crazy. Basically, all this is trying to show you is that you can break up the problem in different ways if you prefer to do it this way instead of like truly using the chain rule. Like this still is the chain rule, but it's doing it in individual parts.
And it almost feels like that, those problems that are like the h of x and the g of x. Just split up the parts up basically.
That's basically what it is, yeah. It's just learn. Basically, you now know how to take the derivative of a function like that. All right, now we're going to find the equation of the line tangent to the curve defined by the given value of t. So they tell us that x is equal to the sine of 2 pi t, and y is equal to the cosine of 2 pi t, and t is equal to negative 1 over 6. So before I do anything, okay, these are technically parametric in nature, the way that they're written, because they're with respect to t and I have x and y separately. To get my xy coordinate that I will ultimately use for the line, I'm going to plug in t into the x equation and the y equation. And then I'm going to get that coordinate that I'm going to use down at the bottom when I'm ultimately done. So this is the sine of 2 pi times negative 1 over 6 I guess I should do this because it's technically all inside of sine there. So this will reduce inside here to be the sine of negative, it's 2 pi over 6, which reduces down to negative pi over 3. And what's the sine of negative pi over 3?
Actually think about this.
Okay, I got it.
Like
Negative, but yes.
yeah.
Yeah, negative root 3 over 2. Are we going to need to have a unit circle quiz before we,
Well, I need the unit circle before I take a unit circle. Need to refresh myself.
I'll just give you a unit circle and make you fill it in. We'll see how much you know. Maybe we'll do that when we're done today.
And that's gonna be the quiz grade.
No, so that you see how much you know, so I know if we actually need to do it or
I know
not.
everything.
I already know.
Like I know all the angles and stuff.
I
That's
know.
the only thing.
I know the angles.
Yeah, I know the easy part.
Well, the only options are 1/2 root 3 over 2 and root 2 over 2. All right. If I put in negative 1/6 in the cosine of 2 pi times that This gives me the cosine of, surprise, negative pi over 3, which would be what?
1/2.
I'm still ready.
1/2. So my xy coordinate, just for the purpose of making sure I can find it later when I need it, is negative root 3 over 2 and 1/2. So now, because of the way they have presented this material compared to what they normally do, basically, we now have y and x, but we don't just have a function and we're taking the derivative and that's going to give us our slope. So we have to do this a little bit differently. We're actually going to take the derivative of x with respect to t and the derivative of y with respect to t. And then we are going to divide the one for y by the one for x, which will ultimately give us dy dx, like normal. Then we plug in the number and get our slope. So, just giving you a little verbal walkthrough before we actually do it. So, dx dt is equal to what? If I take the derivative of this, and maybe it would help to do this.
Okay. So we have to change all our names.
Mhm.
Cosine.
Yep.
Cosine of 2 pi t. Cosine times 2 pi times. What's that? What is that? Is that a problem?
What? What is pi? A number. So it's not a product rule. 2 pi t is a number times a variable.
So
2 pi. So then dy dt, so the derivative of y would be what? Yep.
Then you would divide those? Or wait.
Yes. Now I'm going to show you why. Okay. So normally when we do slope, right, it's y over x. Okay. Rise over run. So we have dy dt divided by dx dt. So basically that is dy dt times dt dx, right? dt over dx. dt's cancel, which give us dy dx. So that's what I'm trying to get right now. Because then I can evaluate that at this t value that I was given originally, and I will get my slope. So dy dx evaluated at negative 1/6 will give me my slope. Okay, so now we'll actually do that. So this is going to be negative 2 pi sine of 2 pi t over 2 pi cosine of 2 pi t. And so initially, what's the very first thing that I can do? 2 pi's are going to cancel. Okay, then inside, now, all I have to do is replace t with negative 1/6. Okay, because that's what I had to begin with. So this is going to be negative sine of, that's going to end up being negative pi over 3 over cosine of negative pi over 3. And because we, thought ahead and went ahead and solved those, other than the negative out front of the sign, that won't always be the case, it just happened. Then that's going to become a positive root 3 over 2 on top. And on the bottom is 1/2. So then keep, change, flip, 2's cancel, and I'm left with square root of 3, which is my slope.
What are you substituting the negative 1/6
t. It just worked out that in this case, it ended up giving us the same thing that we had already solved for up here, but that's not going to happen every time. So now, the square root of 3 is our slope. And then now I do my normal point slope form. What in the... Okay. So point slope form. So our y coordinate was 1/2, so this is going to be y minus 1/2 is equal to square root of 3 times x minus the negative, so plus root 3 over 2. This works out so nicely. So now you can leave it this way, or you can take it farther. So we can have y is equal to root 3x plus root 3 times root 3 over 2 is just 3 over 2 plus 1 over 2 on the other side. And so then that gives me y is equal to root 3x plus 2. And I'm done.
That problem takes so much space in
Well, ordinarily you wouldn't be writing most of like this stuff down. So that would take up a little less space, maybe 1 or 2 lines. I don't know how many you used to write that, but
I just compressed it all.
yeah. Well, and like ordinarily, I probably wouldn't have even written this. Actually, I wouldn't have written this step. I would have just gone straight to here and just written it side by side. But when I'm trying to do examples, I'm trying to like
So we
detail out every little thing for you so that
Yeah.
you have it.
What was the final one? Go back to down to the final one.
Yeah.
We can't do that with these.
All right, I have one more that I can do that's a little easier because it's just x's and y's. There's no trig functions in it. Do you want to see another one that doesn't have trig functions that's done this way? Okay. And then I'll give you problems to do. It'll be faster, I promise. It only took up this much space on my paper this time. All right, so 46 then says x is equal to 2t squared plus 3, and y is equal to t to the 4th. T is equal to -1. So if I evaluate each of those at -1, x is going to be equal to what? So if I plug in -1 for t.
5.
You sounded scared. Y is...
One.
Alright, so my xy coordinate is 5, 1. Okay, so we're already starting off on a better foot than the last one.
Yeah.
Real.
Just not Josh.
Wow.
Sorry, just had to make the joke.
Yeah, I wouldn't take that home.
What? Are you gonna tell me to stand up for myself?
Yeah, stand up for yourself right now.
I can on one foot.
You name Eileen. This is what happens when I'm like super tired.
Yeah.
You're lucky I'm not just like laughing the whole time because that's usually what
When
happens.
did y'all get home?
I got a little before 12, but I didn't go to bed till 1.
Yeah, I didn't go to bed till like 12:30.
We got home like
All right, derivative of x with respect to t.
Like that one. Okay. 4t.
Yeah, just
Yep. 4t. I I almost went for a third, but I
No,
stopped
that's
myself.
a cube.
dy dt.
4t
Just 4
cubed to the cube.
To the cubed. Alright, so then to find my slope, it's going to be 4t cubed over 4t, which is 4 times negative 1 cubed over 4 times negative 1, which gives me
Wait.
Negative
Josh.
4, 1, positive 1.
positive 1.
I was getting there.
So 1 is my slope,
Okay.
and I've already got my point up here. So y minus 1 is equal to 1, so I'm not even going to write it, times x minus 5. So y is equal to x minus 4.
Okay, that was way easier than
That was so easy.
You have to start out a little scary and then,
We'll see. Then
Work
it's
up
so
to
easy
it.
to do the other ones.
yeah, right? See? Okay. Are you ready for problems?
yeah, let me get a picture.
Oh boy. Okay.
Oh boy. Oh boy.
It's just a lot.
Oh boy. Yeah, we have till Monday. It's fine, Josh. Just do like a few problems every day.
Just do it, a few
Or just
problems.
do one.
Love that philosophy.
Or just,
Okay.
or just
What section is this?
4.1.
Oh.
Alright. 1, 9, 19. Did you already write them down?
No, I just guessed.
Oh.
What?
21.
Gave it to us.
Did I already give these to
She gave
you?
us some of them early.
No,
Yes,
we
you
didn't
did.
Yeah, but I didn't write them down last
You
time.
liar. You liar.
Wait, they were literally on the board.
Yeah.
I
They
know.
were.
I'm just writing.
But I don't know if I have any that I took off or
I'm
not.
feeling 25.
Okay, yeah,
Come
Nathan
on.
definitely has them all written down.
No, we don't. I'm just guessing.
One of these I told you didn't know how to do yet, though, I think.
33.
Okay, yeah,
Something.
33. Okay. Now we're to what you don't know
Do we
yet.
have to know them?
Huh?
Wait, do we know them now? Not
Do
do
we
we
have
have
to
to
know
know
them?
Yes, you know them now.
That's not what I meant.
33 is, we did 34, but we hadn't done,
Yeah.
I think, I don't know.
I didn't mean
We won't talk
we
about
have
it.
to. Obviously.
39, 41, 45, and 47.
I thought 43 for 41.
You just like felt the 43.
Apparently, I don't want to do that.
43 is just not nice. That's why I didn't give it to you.
Okay.
It's secant squared of x. You'd have to take the, yeah. That's just a weird one.
Yeah, I guess how that is.
Oh, I thought.
Okay.